In this meeting, we are going to discuss alkane. Alkane is still a topic under your hydrocarbon. So as an overview or a review, alkanes are saturated hydrocarbons, which means that the carbons are not linked with double band or triple band, especially the backbone carbons. This is due to the valence configuration of carbons. There are a variety of alkane isomers which are commonly separated into linear and branch structure. And we have made mention that alkanes are also called paraffins, and paraffins are used in forensic analysis. And we have also made mention in the last session that the general formula for alkane is CH2N plus 2. Adjacent atoms are connected with sigma bands and form tetrahedral centers around the carbon atoms or connected with four other elements. Bands are all single, thus they are free of rotation in all connections in the parallels of its geometrical structure. The carbon skeleton or backbone, as a review again, in naming compounds, this is the longest carbon chain. So this is the general formula for methane, the simplest alkane. The alkane that contains only one carbon. So it is tetrahedral. It is bonded with four hydrogen, and it could also be illustrated in this manner. More illustration shows to you how the carbon is linked with another four carbon. But in the case of methane, of course, these are not carbon but rather hydrogen. Methane, the simplest hydrocarbon, is lighter than air with a specific gravity of 0.550, and it is slightly soluble in water. It readily burns in air, forming carbon dioxide and water vapor. The flame is pale. It is more on the luminous one, but very hot. If you could remember your alcohol lamp or your Bunsen burner, the the flame is near to light blue in color, and it is found at the lower portion of the flame. And the methane has the boiling point of 162 degrees centigrade and a melting point of negative 182 degrees centigrade. Moreover, mixture of methane and air with the methane content below 5 to 14 per volume are explosive. And this is the principle involved in mining, the explosion used in mining, and that is actually an illegal practice. Recalling your hybridization, this is how the methane hybridization looks like. So you have here your molecular cloud formula for hydrocarbon methane. And then this is the stick and ball formula for methane. And this is the geometrical structure showing to you the bonds and the distances. So the distance here for 2 hydrogen is 109 degrees centigrade, degrees, not centigrade, sorry. And you will be doing this structure in your exercise number 1. So that if you are going to make use of the 109.5 or just simply 109 or 10, uh, you will notice that there will be bands that are directly facing you, but there will also be bands that will be going towards you, and there are bands also that is at the back of the structure, and it is illustrated by dashed line, whereas for the wedge or the thick line is the structure that directly touch you. And then this is an example on how we are going to illustrate the structure of the methane undergoing a certain reaction. So you have the carbons. The carbons could be seen as this, and the other one could be away from me, and the other one is towards me. But when this will react with another compound, the structure will also varies. This is an illustration that maybe you have encountered when you were still in high school. This is one of the biogeological cycles that you have encountered. And this is the methane cycle, or the formation of uh, methane gas. I am sure this topic you have met in your discussion on global warming and also on discussion in decomposition or even in composting. So from this illustration, you can see here the human animals and other living organisms forming their own ways going towards the ground, and the digestive system of some termites, digestive processes of animals, and the decay of the waste materials from here all will go to the surface of the land. And in fact, some of the poo for animals, cows, not only pigs, are direct contributors in the evaporation or formation of CH4 or methane to the atmosphere. This is one of the causes of the increase in global temperature or global warming. Okay, these are some characteristics of methane. Methane reacts with steam at high temperature to yield carbon monoxide and hydrogen, causing, of course, increase in global warming. The latter is used for ammonia fertilizers and even explosive. Other valuable chemicals derived from methane includes methanol, chloroform, carbon tetrachloride, and nitromethane. I am sure you know what is chloroform. Chloroform is the one that is used in the preservation of animals. And there were some issues before that involves methanol that is in the poisoning of I repeat that kind of wine in Laguna, whereby it was believed that it was contaminated with methanol and had led to some diseases caused not only diseases but that had caused the death of some farmers that consumed or drank lambanog contaminated with methanol. Okay, another member of the hydrocarbon is the ethane. It contains two carbon. It has also colorless appearance and also odorless uh, characteristic. So this could be some illustration of the molecules of ethane. This is the geometrical structure of ethane. You can see here already that the distance between the hydrogen band to carbon and the carbon to carbon band is 111. As compared with methane, the carbon to hydrogen band is 109. You will be doing this in your activity. So be careful with your measurement of angle so that you could appreciate the three-dimensional appearance of your hydrocarbons. So this is still your ethane. And then the one that you will be doing in the laboratory will be looking or simply be looking like this. So you have here one carbon and the other carbon there, and of course this will serve as your hydrogen. So in the Newman projection, it is illustrated in this manner. And for the softwares, this is also illustrated in this manner. So the one carbon is near to you. So you could see that all the hydrogen are going towards you, as also illustrated in this manner. Whereas the other, since we are following the 111, the other three is going against you. And then these are the common uses of other alkanes. You have there the methane, also likewise the ethane. They serve as natural gas. And then the butane is the liquid that you see in your lighter. And then automotive, and these are also used for automotive and industrial lubricants. Vaseline is also another kind of alkane, and we are using this especially for those babies and those with sensitive skin. Commercial gasoline is also positive with alkanes. If you notice in the gasoline station, there is some advertisement octane. The gasoline is octane, brakes at the 8 carbon. These are the usual lines that you can see in gasoline station to promote the quality of the gasoline. And then also propane. There are some campers that bring with them their liquefied petroleum gas. The one which is small, it looks like a bottle of spray, and it is used as a container for liquefied petroleum gas or LPG. That small container contains either propane or butane or a mixture of both propane and butane. Uh, Tar is also another kind of alkane, and it is used in asphalt. The one that they are asphalto, the very black one used in uh, making your roads in the highway. And then of course the candle wax. These are also alkanes. And not only the candle wax, but also the wax that is present in our lipstick ladies and other cosmetics. Also the wax that we use in floor wax. So generally all wax are alkanes. These are the property of alkanes. Alkanes are inactive compound because the carbon atoms in alkanes are combined together by strong sigma bonds. This cannot be broken easily, except except cases of burning, uh, chemical reactions of substitution, and cracking. Alkanes are unreactive. The first one is inactive. The alkane is also unreactive, but not affected with mineral acid. However, at higher temperature, they are sensitive with mineral acid. Alkanes are not affected by oxidizing agents. This is again due to the sigma bond present in carbon. Alkanes burns with alkanes burn giving water vapor to carbon dioxide heat. This is the thing that is seen in geothermal plants. And then another reaction whereby alkane is very active with is the process of substitution, especially with halogens. Alkanes react favorably with halogens by heating up to 400 degrees centigrade or in the presence of indirect sunlight. In the laboratory, we usually perform to illustrate activities like this, whereby uh, the change in color of a certain thing added with an alkane plus sunlight contributes to a change in color from dark to light. And this is also the same principle involved in our washing of clothes. The reaction of bleaching agent to the organic substance cloth and then exposed to sunlight, then it will become more white and bright. Okay, here are some uses of halogens or halogenated derivatives of alkanes. So chloroform. Chloroform, or with the formula CaCl3, is used as anesthetic substance. And this was used before, but not until it was discovered that if not properly performed, if the volume is not properly quantified, it could lead to death. And then we have also here uh, another important halogenated derivative of alkane, the 2-bromo 2-chloro 1111 trifluoroethane. This is a halide that is used now as anesthetic substance to substitute chloroform. Of course, the active component do not only depend on chloroform but also on another uh, halogen, the bromine and fluorine. So you have the three halogens here, the bromo, chlorine, and fluorine. So how to read this? I repeat, tobromo, tobchloro, 1111, trifluoroethane. Simple. And then another halogenated derivative of alkane is the 1111 trichloroethane, and it is used in dry cleaning. The dry cleaning of more on the side of the wall rather than the bottom. Freons, this is the liquid that you are adding to air condition, refrigerator, and even to air condition in both cars and house. However, to environmentalists, we do not favor for the use of freons as the cooling agent for car, neither in houses. There are now available uh, coolant added to air conditioners and refrigerator that are negative with chlorofluorohydrocarbons. Because the continuous exposure of the hydrofluorochlorocarbons in the atmosphere leads to global warming. Okay, another topic in alkanes is how these are prepared. And this could be prepared by reduction, hydrogenation, reduction of alkyl halide hydride, and also reduction of alkyl halide zinc or acid, Grignard formation and destruction, coupling reaction, Wurtz reaction, and the Quarry house coupling. In this slide, you can see here one of the chemical activities whereby an alkane could be produced. So if we say production of alkane, it is the production of single CC bond. The reaction should produce a single CC bond. So here is a compound containing carbon, so it is organic compound, but here you could see the presence of the double bond. So since this is a double bond and you need a single bond, you have to break this. How to break this? By the addition of hydrogen. But the addition of hydrogen is actually breaking hydrogen molecules or the gaseous hydrogen form. So this is, if written in the blackboard, this is hydrogen bond hydrogen. So I'm sorry we don't have the blackboard. Usually if I discuss this in my class, I use already the blackboard. So you have here now H dot dot H. Whereas here we have C and then one bond, X there, and X. So the X here will be falling in love with one of the dot from hydrogen, and the one X here will also fall in love with the one dot coming from the H2. So forming this one. So this two is used to be this one. So leading to the breakage of the single bond, thus forming the single bond for ethane. Were you able to get it? So this is hydrogen, hydrogen. That is the hydrogen and hydrogen there. The hydrogen and hydrogen, it is still here. But what happened is, para masira yung relasyon nila, dapat sirain mo yung double bond into single bond, and destroying it, just like in relation, is to break it and change it or add more uh, bonds. So you have here the bond with hydrogen coming here and the bond of the hydrogen coming there. That is the same true with triple bond. You just keep on breaking the bond until it will form double bond and then eventually the single bond. And then we have also another mechanism to prepare alkanes is the reduction of alkyl halide. So we have here an organic compound with a halide. So what is supposed to be done is just the same as the first slide. You have to add H2 so that this halide will go out. Ito, hydrogen, will fall in love with one of the hydrogen here, thus forming an acid, hydrochloric acid. And the other hydrogen will be added to here. So making this CH3, CH2 plus 1 coming there, that will become CH3. And since there are already 4 bonds for this carbon, you have to remove the Cl already, and the Cl bond will be bonding with here. So I repeat, this hydrogen will be working with chlorine and the other hydrogen will be working with carbon. Hence, forming CH3, CH3 8 plus HCl. The same could be illustrated in this manner. And then you have Grignard reaction formation. Put this into your mind. If you say Grignard, you are actually working with magnesium. So R there could be anything that is with alkane. And then here is your halide. X is halide. The X could mean FClBrI. So when illustrated, you have here the R. Ito yung R dito ngayon. It is the phenyl ring. And then the X or the halogen is the bromine. And this is your Grignard reagent. So what will happen? relasyon si magnesium kay bromine. Once si magnesium had merged with bromine, eto na yung kailangan. This is now the product. Okay? Another reaction. You have the carbon to carbon bond formation using a nucleophilic reaction. So the nucleophile could mean the copper, nickel, iron, or any transition metal catalyst, breaking again the R double bond into single bond. So the electronic partner, which is with this halogen, ito yun, and then the nucleophilic partner, one with this, will form this one, or it could be illustrated in this manner. So you have here eventually the carbon to carbon na single bond. Nakuha nyo. Dito kasi puros X and the nucleophile ang kapartner ng mga R. So, ang mangyayari is, si R, makikiband muna kay R. Kanya, ito yun. Pero ang problema, double band yan. Ang kailangan natin is single band. So, further reaction, ultimately will break the double band to form the single band alkane. And then, we have the word splitting reaction. Parang ganun lang, but what is used here is the ether. Okay, last we have the Quarry house coupling. This is the reagent to be used in the Quarry house coupling, and the target is to destroy this. So that eventually, what will be left is the CH3CH2 single bonded by removing the bromine there. Nakita nyo? Si CH2CH3, pinalipad natin dito. Yung paglipad niya dito, natanggal si bromine. Yung pagtanggal ni bromine, siya naman yung pagsalo ni lithium sa kanya. Of course, si copper will be working further with the Quarry house coupling reagent to form this one. Kasi dalawa ito, yung isa pumunta doon, yung isa naiwan to maintain the relationship with copper. Kasi kawawa naman si copper. Iniwan ni lithium. So take note, the relations that happened is